So today we're going to talk about the production function and short-run costs. The idea, so production function is the relationship between the quantity of inputs, workers typically, and the quantity of outputs. A term involved with the production function is marginal product. Marginal product is the increase in output that arises from an additional unit of input. Increase in output that arises from an additional unit of input. Remember, rational people think at the margin. Okay, that's marginal product. So let's take some data. We're going to do a cookie factory. So everything is fixed but the number of workers. This is our data as a result of this. We have our number of workers, our total output of cookies per hour, and then the marginal product of labor. Since labor is the variable that is changing, we call it the marginal product of labor. As you can see, that's the column on the right. Everybody understand how we got the marginal product of labor values? It was the change in total output. That's for each additional worker. It's a change in total output. Okay, so if we graph this data, it'll be a challenge to fit it in on this PowerPoint, but I'm going to try to graph it. Okay, if we graph this data, we have a production, we're graphing a production function. So for our production function, the vertical axis is, oh, I just lost it. Here we go. Try again. So we graph the production function. The vertical axis is quantity of output. And this would be, in this case, cookies per hours. And the horizontal axis is the number of workers hired. Okay, so we had data up to 5 workers. So 1, 2, 3, 4, and 5 workers. Okay, and then on this axis, we'll try to squeeze in the number of cookies. It goes up to 150. So I'm just going to do it in increments of 5, so I can fit the numbers. So we have 10, 20, 30, 40, 50. 60, 70, 80, 90, 100. And then we've got 110, 120, 130, 140, 150. 150 workers. right? So if we plot the data, at one worker we had a quantity of 50 cookies. With 2 workers we had a quantity of 90, so that would be there, about there. For 3 workers we had a quantity of 120, so 100, 120 would be here. 3 workers, 120. For 4 workers we had a quantity of 140. And for 5 workers, we had a quantity of 150. Okay, so let's make these bigger. My stylus is not working too well. All right, so then if we connect the points, we have a graph that looks like this. Okay? So what is happening to the graph? What is happening to this production function? What's happening to the graph? Describe it. What's happening to the graph? It's getting flatter, right? It's plateauing. Yes, getting flatter. So what is that indicating? The graph getting flatter. What's that an indication of?
It caps off eventually, the quantity of outputs.
Okay. What do you mean by caps off?
Once you get to a specific amount of workers, like too many, you're not going to make as many, or the slope isn't going to be as high.
Yeah, that's right. The slope is getting less, right? It's getting flatter, okay, and that's what we call the diminished. That is showing the product of diminishing marginal product, and that's saying as we add workers, and we'll define it here in a minute, but as we add workers and keep all the other inputs the same, eventually it becomes inefficient, and we're not increasing our marginal output. And in our case of the growing rice, it actually went negative. We were producing actually less because we hired more workers. So that's the important concept here. Now let's graph the marginal values. So at 1 we had 50, and at 2 we added 40 cookies when we hired 2 workers. We added the 3rd worker. That worker added 30 more cookies. We added the 4th worker. That worker added 20 more cookies. And we added 5 workers. That worker added 10 more cookies. So there we have, this is the graph of the marginal product of labor. Again, what is this the graph of? The marginal product. What is it the graph of? Yeah. It's the graph of the slope of the production function, and the slope is getting less and less, and that is shown by the marginal product. Again, that's the calculus students. That's the what? That's the derivative of the production function, the graph of its slope. You can see it shows diminishing marginal product. All right, does everybody have that information? Okay. So let's define, so the graph was getting flatter, and this shows diminishing marginal product, and diminishing marginal product is the property whereby the marginal product of an input declines as the quantity of the input increases. Okay, other inputs held constant. So the graph gets flatter as the number of workers increases. This is a short-run phenomenon. Why would this be a short-run phenomenon? What could the rice grower have done to stop this diminishing marginal product to some extent? Yes. Right. He could have acquired more land so they wouldn't be crowded. What else could he have done?
Stop having workers.
Yeah, but he probably wouldn't want to do that if he wants to increase his output. What else could he? What else was a factor in the causing diminishing marginal product?
Resources.
Like what? Give me an example.
Like in our example, or like in a
In your thing.
the chalk.
Yeah, chalk. Maybe that's your equipment, right? Buy more equipment so the workers' workstations are not crowded, right? That type of thing. So you add other inputs, then you won't necessarily have as much diminishing marginal product, or you may even have increasing marginal product. Technology is another thing, right? If we could get, some kind of automated thing to write the rice on the board, it wouldn't take as much room. So on. Okay, does everybody have all that? You got it, Zane?